Okay, so you're going to have to bear with me on this one. We're comparing characters. We found that we've got a problem. When we did lowercase a, it wasn't bigger than m when we were comparing it against m. When we did lowercase z, it said it was bigger than m, what we expected. However, when we did it with uppercase characters, we got some strange results. It said that a is not bigger than m, which is what we expected, and then we typed capital Z and it said it's not bigger than m, which is not what we expected. And the reason is quite straightforward, and I'm going to take you to Google again. I'm going to type in something called the ASCII table. Now this table gives you all the characters that you can type in at the keyboard, and probably a few more. Let's see if I can find a useful one for us. Here we go. And it starts on the left hand side, and in fact this one doesn't start right at the first character, but it doesn't matter, it starts at 32. It goes from nothing, 0, all the way up to 127. So if you can see this deck, these are numbers are going up to 63, 64, 65, so on, all the way up. And all the characters that you type on the keyboard are given a number. So if I typed lowercase a, it is given the number 97. However, if I type the letter capital A, it's given the value 65. And as you can see, 65 is less than 97. But notice when we typed capital Z, the number that was given was 90. And when we were comparing it against lowercase m, well, lowercase m is 109 and 90 is less than 109. So really that's what was happening. It was looking in this table and seeing whether the number that represents it, it was comparing it against that. So basically all the capital letters come before all the lowercase letters, and a few square brackets, odd characters that you can type in at the keyboard as well. The digits are down here. They start at 48, 49, 50, 51 and so on, right there up to 57. So if I was to compare whether 9 was less than lowercase m, it would be true. If I was going to see if 9 was greater than m, it would be false, and we can see that straight away. So let's go back to my program and run it again. So this time I'm going to type 9. What we're looking at, we're saying, is the character greater than m? Well, we've just seen that 9, I'm getting into a mess here, let's scroll this out of the way. 9 was 57 and lowercase m is 109. So if I type in 9 being bigger than m, that's going to be false. It is not bigger than m. However, if I went back to my program and if I was checking against this character 9, it's not the digit, it's not the number. So I would need to put the 9 in speech marks. It's text. This is all text. Okay? The dollar sign, the percentage sign, and so on, they're all text. So if I changed that and that to 9, I can now check whether the character m is bigger than 9. Well, 9 is 57, m is 109, so that should work out to be true. Run module. So please enter a character. I'm checking it against 9, so if I put in m, it says it is bigger than 9. If we take a look in our table, I've got things like the ampersand, the percent sign, the dollar sign. They're all less than 9. So if I run my program and check that, so if I type in the percent sign, that should be less than 9, and so it would be false, and it will say it's not bigger than 9. And there we go. So that's what's happening. We're actually using a table of characters, and they have got an order in the computer. So the computer knows what number each character represents, and you can do a check of the actual number, the decimal number, well, it should be an integer really, that character represents. Very difficult to get your head around, but we'll have a look at one more little piece of programming with strings, just to see how it all works.